let's try to solve a Leetcode problem today. Today we are going to solve number 30, substring with concatenation of all words. Yeah, let me go to the whiteboard to explain what about the description, and then go to the code editor to finish it. Yeah. So the problem is straightforward. We have an input string like this, and we have a words like for and bar. We want to return the result of the index, but from this index will include all the word inside the words. For example, from index 0, here is bar full, it's included. Yeah, so we're gonna put a 0 inside the result. And for here, we have a full bar, so we used all of the words. We have a 9 because this index is 9. So we're gonna return something like this. But how we are going to do it? Because we are also told that the word, inside the words for this full bar, the length of them will be the same. For example, this length is m, it will always be m. Yeah, so this is also useful for the algorithm. So for this one, we are going to use brute force to solve the problem, but we also need a trick. We need to use a counter. Yeah, we cannot use the set because we need to include all the word inside this word. So this is why we have to use a dictionary. So we are going to use a counter. So for each of the index, like from here, this B, we're gonna check. Can we find? If we find, we just break it. Yeah, we don't need to find anymore. We break the loop and go to the next. From here, can we find? No, from here until here, we find. Yeah. But how we are going to use this approach, and how we are going to check if we find the variable with this one. So for the word, we are going to use a count. So this count is a dictionary. Yeah. And from here, we are also going to prepare a count. So this count, I will be prepare a frequency count. Yeah. So if the frequency dictionary equal to this count dictionary, it means we find one. So we are going to append this index to our result. Yeah. And then when we go here, we find another one. We are going to append another index 9, and then just to return the result. Yeah, I think it's easy to understand, but it's also easy to make mistakes because we have to use all our calculations to check. Yeah. Now let me go to the code editor to code it up. Yeah. And when I go into the code editor, I want to keep this strings here so we can, yeah, basically we can understand clearly about what is going on, yeah, about the string. So for the first step, we are going to define some variables. So we are going to define a result. So the result should be an empty array because we are going to return this result. And I also needed to define a word less. So the word less variable is inside the word is like the length of the full or bar. Yeah, it should be length of words 0. I also need the words less. So this is the length of the words array. Yeah. So I need words length. So let me put the length of the words. Yeah, why we need? Because we need to use this to put them into the count and check if the frequency count equals to our count. We also need to define a count. So the count would be the dictionary. Yeah, let me put it bigger. Yeah, let me try to put it wider. Yeah, and the count would be the counter of the words. I'm also going to define a variable n. This n will be the length of the string because I'm going to use the for loop to loop this string s. So for I in range. So from here, we are not sure what is the length of this variable words last times the word last. So we are going to let it stop earlier. So from here, we are going to minus the word length times the words last and plus 1. Yeah, plus 1 is because of the Python. This one is not included. For example, this number n is 11, and words last times words last equals to 10. So this 11 minus 10 is equal to 1. 1 plus 1 is 2. It means we have two combinations. Yeah. So for example, this array, we have something like this string is 11. And for each of them, we'll 10. So we'll start from 0 index and index 1. So for that 0 and 1, we have all the combinations. Yeah. So this is why. Now let me continue. So this is the first outer loop. And for the inner loop, before the inner loop, we want to define a frequency. This frequency will also be a counter because we want to check if the frequency equals to the count. Yeah. And then inside the outer loop, we have an inner loop to put each word inside the frequency dictionary or counter. Yeah. So for Z in range, so it will start from I and I plus word last times word last. Yeah. Yeah, because for example, this is a 6. Here is 2 times 3. It is 6. So here means this I plus 6. Yeah. And it going to jump. So how big it should jump? So the jump should be the word length for each of them. It means you are not going to check one by one. You have to jump. So for the first one, you find a bar, and then you jump to here, to this F. You're going to find a full. You are not going to check one by one because that is too slow. You have to jump. Otherwise, I think it will be time limit exceeded. You have to jump. Yeah. You cannot use totally brute force. You have to jump a little bit because it's also straightforward. You are going to check the length of the word, and each of them has a fixed length. Yeah. If it is fixed, why not jump for the fixed length? Other than one by one, it will take too much time. Yeah. Now we are going to find a word. So the word should be, yeah, we are going to define a word. So the word should be S. We'll start from Z and Z plus this word last. Yeah, because it will be a word. For example, here the length should be 3. So we are going to check the bar of full first. So the length would be 3. So if this word is inside the count, so inside this counter, we divide the counter words. Yeah, if it is inside the count, it means we find one. So what we're gonna do is we're gonna update the frequency counter. So the frequency counter should put a word and plus 1. So this is the condition where we find 1. But what if it is not inside? If it is not inside, we just need to break. Yeah. So outside this for loop, we are going to check if this frequency equals to count. So for Python, we can directly compare the frequency equals to count because this just takes the time complexity of O(n). N is the length of the frequency or counter. Yeah. If it is equal, so the result should be append this I because we are going to append the outer loop, this I. Yeah. So from here, I think this is basically the entire code. If I didn't make any mistakes, I think it should be okay. Yeah. Now let me just run it to check if it really works. Yeah. Yeah, lucky for me, just one time, this time it works. And let me submit it to check the time. Yeah, it would be very slow, but I still think it is okay because it is a hard problem. They have so many eliminations for the result. Yeah, it is still okay, like 10% of all submissions. Yeah, even we can optimize a little bit, but that is basically the entire code. Now let me optimize a little bit, and after that I'll analyze the time complexity. So from here, as we know, this frequency inside this k, this w should plus 1. So if this frequency word is more than the counter of this word, yeah, if it is more than the count of this word, it means we need to break first, break earlier. So if this is more than the word inside the counter, it means we should stop earlier. So we need another break. So from here, we can just break this for loop and go to the next. Yeah, but basically this didn't improve too much. Now let me submit it to check if it improves or not. Yeah. Yeah, of course, we can also use some other variables, like we use each word we use yeah yeah, but basically it also slower, but it doesn't matter anyway. We pass all the testing cases. Yeah. Now let me go to the whiteboard to analyze the time complexity. For this time complexity, we basically needed to analyze these for loops. Yeah. So here are for loops, and inside the for loop. So this is the word. Yeah. So inside the for loop, for example, we have a word. We just needed to check this word inside the counter. Yeah, so here we also needed to check the length of the word. Yeah, for example, the length of the word maximum maybe 30. Yeah, let me check. So this is 30. So here basically we take the time, the length of the word 30. And here we have two for loops. So these two for loops basically we needed to calculate. Yeah. Now let me copy these two lines of code to the whiteboard to analyze a little bit. Yeah. I'm not sure I can use the copy or not, but let's try if I can copy. Yeah, copy the code. Yeah. Yes, basically we need to analyze these two lines of code. So here is a for loop. For example, we know the length of the word, the length of the string, it is n. So yeah. So here we have a n, and here the word length and word length we need to use minus. Inside, let's make it the word length is x, and the word length is y. Yeah. So n minus this one, the plus one we don't need to check that. Yeah, and times. So here we are going to check this word length. Yeah, because this is how many jump. This is the jump. Yeah, the word length is we are going to define the word length as this number x. Yeah. So and also needed to times this y, because this y is the x is wordless. This y is the wordless. Yeah. So this is basically the time complexity. But for calculation, basically if this x is because this n is 10 to the power of 4, and this x is 5 times 10 to the power of 3, and this y is 30 maximum. Yeah. So when we are calculate, we don't need to count this y. So before this formula, basically, we will define this y as 30. So the result would be n would be maximum 10,000. So 10,000 minus x minus 30 minus 30x and times x. We are going to calculate this x. Yeah, and then we can use the advanced mathematics to calculate. So basically, this result is one. Yeah, it's basically this result is to the order of O(n). Yeah, because if we calculate a little bit, let's put it 10,000 divided by 30. Let's put it 300. Yeah, and minus x. So it means 1x equals to 150. It should be the biggest. So 150 basically square. It is 225. Yeah, it means 22,500. So it is to the order of O(n). So this is the O(n). So from here it is 30 y. So that is why the time complexity is y times n. It is 3. It is basically 10 to the power of 6 maximum. That is why we can pass all the testing cases for Leetcode. Yeah. Thank you. If you think this is helpful, please like and subscribe. I will upload more Leetcode